Hello, my name is James Haber and our mini-project is about the effects that trampling can have on species biodiversity. I will now start with our introduction. To begin with, we produced some aims and a hypothesis to focus on what we were going to achieve as well as what we thought would happen at the end of the study. This allowed us to develop a project that would be straightforward to carry out, but at the same time producing sufficient detailed results which provides an opportunity for discussion regarding trampling and its effects on species biodiversity. The main aim of our project was to really understand the effect that human trampling can have on the abundance or diversity of plant species within an area, as human involvement can seriously damage ecosystems. Additionally, we wanted to identify trends between different study sites, which can provide the opportunity for comparison of results and a detailed discussion on the findings. A hypothesis was then later developed and predicts that the abundance of plant species will increase along the length of the path as human interaction decreases. To achieve the aims of the project, we chose the study site of Delston Country Park, which is located in Dorset and provides the ample location for our project. The country park is widely known to be one of the most biodiverse locations in the UK, providing a habitat for numerous species with its many fields. It gives our study many different sample locations. This allows for the study to compare the results of different fields with each other, enhancing the detail of the overall project. To narrow it down more specifically, we chose to sample 5 particular fields around Delston, and these can be seen on the map here. We began with Southfield and moved on to Saxonfield, Oxeye, Centenary, and then Heron Ground. These are all in a relatively close proximity to each other and were chosen specifically to enhance the investigation. These fields were chosen because several of them were sown with seeds 30 years ago to encourage conservation efforts, while some were not, but conservation was still encouraged. This enables comparison between the results, as those fields that have been sown with seeds can be compared with those that were not. The presence of Southfield as a practice field also allowed for the testing of results and an example of how the project would be carried out in the other fields, with it being located closest to the car park. I'm now continuing on to the methods section of our mini-project. In order to acquire sufficient results for our group, we utilised one 0.25 metre by 0.25 metre quadrat, a 50 metre tape measure and notepads with tables to take notes of the results. This equipment was then utilised to collect the data required for the study. The process of data collection begins with the transect being laid at the gate of each field where the path is most visibly trampled. This provides an opportunity for comparison with gates in other fields as well as with the results collected from the pathways. Following this, 10 steps will be taken away from the gate and the 15 metres is measured from this point down the middle of the path utilising the tape measure. Transects will then be placed at 5 metre intervals, including 0, directly on the centre of the tape measure, and then another transect will be placed on the edge of the path at this interval. This edge will be the one closest to the middle of the field, and then a further measurement will be taken 1 metre further into the field. During this process, certain measurements will be recorded. Firstly, the number of species within the transect will be noted to display the variety of species present on the pathway. The average height of the grass within the transect, and then the percentage cover of forbs, grass and shrub will also then be recorded to provide more details on what is within the transect and on the path. In addition, the distance between the middle of the path and the transect on the edge of the path will also be recorded to showcase the differing widths of some paths. The data process has been structured this way for several reasons. Firstly, 15 metre provides a sufficient distance to measure trampling and can provide an indicator of how species biodiversity changes as you go along the path, providing valuable data for the investigation. In addition, collecting data at gates and the measurement of the distance between the middle and the edge of the path also enhance the project by providing more methods of comparison between the different fields. As well as this, multiple fields were chosen to achieve the aim of discovering trends across the general area of Delston. This allows for a project that can assess the effect of human trampling over a large area in fields that are under different conservation designations. Finally, the data that will be collected from the quadrats was chosen to be collected this way as there's lots of comparable data which provides room for discussion. I will now pass on to Jodie, who's covering our results.
So I'm going to be talking about the results that we got. As you can see here, we've plotted the number of species we have observed in each quadrat against the distance from the centre of the path. And we've done this for each field as we've gone along the path. And the general trend that can be seen is of increasing diversity as you get further from the path. And we've added these trend lines which help you see that. We've got the R-squared values of the trend lines here just so you can see how good the fit is. So overall, for all of the fields, we've got the same trend of it increasing diversity as you get further away from the centre of the path. Here we've got the percentage cover of each quadrat that we took. So we measured it in terms of grass, forbs and bare. and as you can see, mostly the quadrat, it tends to be made up of grass, with a bit of variation here and there, but mostly grass. And then we have some bare patches, usually largest 0 meters, which would be the center of the path, and then getting smaller and decreasing with the distance you get from the path. Forbes in red has a bit more variation, but tends to be the opposite. So as you increase the distance from the center of the path, the percentage cover of forbs will increase. And lastly, here we have the vegetation height. So we took the average height of the vegetation from each quadrat, and we plotted this against the distance from the center. So you can see this also tends to increase the further you get from the center of the path, the higher the vegetation. It can be seen across all the fields. The height does vary. For example, centenary, we reach heights of 50 centimetre, whereas in Saxonfield we only reach 30 centimetre, but the same trends can be seen across all of the fields. So overall, with increasing distance from the centre of the path, we see increasing diversity, increasing forbs, percentage cover of forbs, and increasing height of the vegetation. And we also tend to see less bare patches.
In this first part of the discussion, we're talking about Southfield, Saxonfield, and Oxeye. We use Southfield as a practice field to refine our research skills. In doing so, we changed our observational methods from a DAFA score to percentage cover. We did this because DAFA is more appropriate for analysing large areas such as fields rather than quadrats, so we went for estimated percentage cover. We also trialled the transect points that were perpendicular to the path to make sure we did not intrude too far into the meadow because of its ecological importance and it being a habitat for skylarks. Overall, we used the Southfield to get into a routine of the investigation. We practiced each method multiple times so that we were quick, efficient and precise at recording the data. This was so we could comfortably undertake the investigation within the time constraints. Saxonfield. Saxonfield had tall shrubs near the path that created shaded areas, which in turn creates areas of low biodiversity. Blackthorn bush is one of these species that grows close to the path and has the effect on the biodiversity. Long grass was also found in Saxonfield. This long grass often creates less biodiversity because shorter species cannot survive. The grass along the path of the field had recently been mown, which affected the results. If we had recorded the results a day earlier, then the data would have been completely different. The ant hills in Saxonfield stopped the meadows from being mown as much because the machinery cannot get over them. This means the areas surrounding the mounds are much more diverse. Saxonfield was also the closest field to the car park that we recorded. This is important to note because it is likely to have been the most affected from trampling. Oxeye. Oxeye contained larger plants such as the Carlisle thistle. This species was found in one of our transects and may have affected the results due to its size and cover, which could have easily hidden other species that we may have missed. In Oxeye there were no shrubs close to the path. This means that the field had more light to let in, but it could also mean there was less cover from winds and rains, which potentially influences biodiversity. This field also contained lots of quaking grass and common short grass, which are common species to find in short grasslands.
This section covers human interaction with the site. On the left is Heron's Ground, and on the right is Centenary Field, the last two fields we did in our investigation. Results further away from the centre of the path showed a decrease in bare ground and an increase in forbs and grass. This is evident from our results. This therefore shows us that species diversity increases with distance towards the centre of the field. Our results also show us that species height increases as distance towards the centre of the field decreases. It is evident from the results that the lowest species diversity occurred in the centre of the path. This is mainly due to trampling by visitors, but also regular mowing to make the path clear and prevent people from wandering off them by accident. By mowing the paths, only really low-growing grasses and forbs are able to grow, explaining the low species richness in the first quadrat of each set. Paths may also be widened due to visitors not staying to the path but walking around. Usually in winter this is because people don't want to get their shoes muddy, so will avoid following the path but walk to the sides, therefore widening the path. We moved the quadrat closer towards the centre of the field each time, as we were trying to show a representative sample of the field. Going towards the centre was more appropriate than towards the edge, as the edge sometimes was less than a metre away from the path and had walls and shrubs. There were no shrubs in Centenary Field and Heron's Ground. This means long grass and other species at lower levels are able to colonise, and there is reduced competition and no shade. The investigation also helps us to understand levels of conservation success at Delston Country Park. Centenary Field and Heron's Ground were both put under conservation plans 30 years ago. Heron's Ground was sown with seeds, and Centenary Field wasn't, probably to compare different levels of plant species diversity success between the fields. Our investigation results were limited, as there was a limit of the distance you were allowed to go from the path. This was 1 metre, and subsequently we were not allowed to take results from the quadrats past this. Another factor potentially causing less representative results was much larger species, such as the Carline thistle, hiding other species under its leaves, although it is unlikely that many plant species would be able to survive successfully underneath. To conclude, it is clear, aside from anomalies, that as you move further from the path and closer to the centre of the field, species diversity increases. The number of species increases, indicating successful conservation, whilst we face challenges collecting our results and ensuring they are useful. The project was a success and informed us of more and less successful conservation over the years between the different fields. Recommendations. The point of our project was to investigate the effect of human interaction has on species diversity in the form of trampling on a footpath. The hypothesis stated, with increasing distance along the path and towards the centre of the field, the diversity of plant species will increase. Generally, the results we got prove the hypothesis. However, some results do not always show an increase in species diversity, as the quadrat have moved towards the centre of the field, indicating there are areas for improvement in the investigation. Species richness along the path demonstrates a gradual increase, showing that there was success in the distancing and total length we chose for the measurements in this area of the investigation. Unfortunately, travelling more than 1 metre off the path was not allowed, so even though results may have been more representative of the overall species diversity in the field, we would not have been able to take results further than 1 metre from the edge of the path. If there were no restrictions, taking quadrat samples closer to the centre of the field would have increased validity of results in representing increase of species diversity the closer you get to the field centre. We faced some limitations throughout the project. One of these was that our ability to spot each individual species was hard, as none of us have much experience in that area. This meant that we may have miscounted number of species within the quadrat unintentionally. The miscount may have occurred where species look similar, specifically when looking at different grass species. To prevent this affecting results, research into species in the area could be undertaken to ensure all present species are recognised and counted. Another limitation, as spoken about earlier, was the larger species covering large areas of the quadrat. An anomalous result occurred due to the Carline thistle taking up nearly 40% of the quadrat area we were investigating. This could be solved by stating that if an anomalous result is likely due to obstruction from a larger species, the quadrat may be relocated to the left or to the right of the original position, although this may also provide more useful information if the method is unchanged, as a larger species will compete and reduce chances of smaller species surviving.